Okay. Yeah, sometimes I get some connectivity issue. It's very annoying though. It's very annoying. I don't know how to solve it. Sometimes OBS just goes down. It sucks. Okay, now I should be live and shouldn't have connectivity issues. Okay, okay. So we are doing this logic thing. So we have this problem of sharing the fees cross-chain, and so okay, so we have a liquidity provider that deposit 10 on ARB, right? On Arbitrum, right? So here basically I got a little -5, and here I got plus 5.5, right? So then the net situation is I have 5 WETH on Arbitrum and 5.5 WETH on base. Okay, so so how the liquidity provider is going to get his fee plus his deposit? So he can get basically all the 5 WETH. He should be able to get 5 WETH from Arbitrum and 5.5 WETH from base, right? But how? So I was telling about minting the liquidity provider's new tokens every time there is a new movement, a new teleport. But this is very expensive, and it will be like not ideal, because you have many liquidity providers, so you need to basically mint and burn every time you have a teleportation, so it's not good, right? Another way can be when the liquidity provider deposits on one chain, he could send a message to the other chain, and he could basically mint. He could also have there the same amount of LP token, right? So, but this is kind of wrong, because then you have like double entry problem, right? Because let's see, if you are here and you are here and you deposit here, right? You deposit here and you get LPs, LPTs, yep, you get LPTs here, so it means that you have this value here of 10, you have 10, then you can send a message here, it's our CCIP, and then means that you also have 10 here. Maybe this can be a solution. Let's see if it makes sense or not. So we have 10 here and 10 here, but actually this 10, like this 10 arbitrum is actually worth 10 WETH, and this 10 is worth, okay, maybe this can be good, this is worth 0, right? So in the case of, in our case, then we will have this. In our case, maybe this can be a solution. We have in arbitrum, we have 10 LPTs here and still 10 LPTs here. That can make sense. That actually can make sense. And we have 5 here and 5.5 here. So when I deposit in one pool, I have 10, but then, yeah, but this makes sense, but no, because if I have other LPs, if I have other LPs, and maybe the other LPs are just depositing here, and just depositing here, then I come here, I deposit here, and I get 10 liquidity provider tokens on base. So this means that I deposit anything on base and I have the right to withdraw the value of 10 LPTs from base. So it doesn't make sense. So this is, maybe I'm going to, yeah. Just 1 second. Yep. So maybe I'm going to not go on with this. It would be okay if you only have one liquidity provider, but or wait, because when I mint LPTs, I deposit. Let me check the function. By the way, it seems that I managed to solve the problem with my VS Code. So in my VS Code, I had this problem of errors for the remappings. So what I did, I went to settings.json and added all these things, all solidity.remappings, Unix, remapping windows, and finally it looks like it's working. I cannot guarantee that is the correct way to do that, but okay. So let's let's go in cross-chain pool and let's see how do I mint this, like the deposit function, deposit here, calculate mint LPTs, okay, mint LPTs to LPs and get underlying in exchange. Yeah. Follow, okay. Maybe I'm gonna delete that. LPs, maybe I'm not gonna delete, but I'm gonna do like custom. Security. I'm just gonna move to the bottom. Okay, so mint LPTs. LPs cannot deposit cross-chain. And then the deposit amount, LP, calculate LPT in exchange of underlying. So okay, calculate the correct amount to mint for the input underlying, total cross-chain underlying, total cross-chain LPT. So I need to understand the total cross-chain underlying, the total cross-chain LPT, amount to deposit. So actually, maybe just thinking. Okay. So I'm thinking, so I have 5 and 5 here. So this guy means the value is 1, 1. So this is like 1, and then what if another LPs come here, in this case, he comes here, call it, we style differently, the pink. So he deposit, the deposit, we say that the formula is amount of what? Total cross-chain underlying, total cross-chain LPT. So this guy want to deposit other 10, so he will get so 10, from him. From him and five from which are owned, well, which deposited by this. Yes, 10, yes, 5, and he you know what, I'm gonna do that. Okay, and then he gets, so the amount is equal to total cross-chain underline, total cross-chain LPT. So amount of this guy is total cross-chain underlying, so it's like 5 total cross-chain under. Okay, so it's 5 plus 5 plus 5, so it's 10 plus 5, 10, 5 on total cross-chain LPT, so it's 10 and 10, 20. In this case it's 20. It's like 0.5. No, doesn't make sense. In this case, this formula doesn't apply. In this case, this formula doesn't apply, but it would apply. It would apply referring to the single pool. So the total supply here is 5 wet, and this, the total amount of LPTs is 10, right? So he will get, right, is correct, LPT in exchange overnight. So he will get basically 5 on 10. But this is very unfair. Can be. Ah, no, okay, is amount, okay. So this is 1 LPT, right? Times amount, which is, we said, 10. So it's like 5 LPT for this guy here. Then here I need to, so this is the situation, right? I'm just gonna duplicate, sorry. Just going to do that, make it copy. Okay, so he has now 5 LPT. He gets 5 LPT and he deposit 10 WETH, but here, what does he get here? So here, you will have I cannot move this. Okay, here I will have 10 of these, and then maybe this guy want to, of course, let's say we mint at deposit time LPTs, he will get So total width is 5. Up. Total LPT is 10. That can make sense. And the deposit on the other thing, so it's like this value comes through CCP. TCP message, right? So the total that it gets here is, well, 5.5, 0.5 something, 5-ish. No, is 5.5, but yeah, so the amount is not 0.5, but the amount is 5.5. LP. Yeah. So he gets this, and then they want to withdraw, and they have 5. So value of 1 LPT, we say that is 1 of this equal 5.5 width, right? That doesn't make sense, because here you don't have, you only have 5.5, so yeah, it doesn't make sense. I cannot do that. I cannot do that. And that's fair. I mean, that makes sense. Yeah. You cannot mint the same LPT amount to maybe I can do another way. So here I mint 5 LPT. That makes sense. Then here I don't mint the 10. Why I divided by 10? Because it's the total LPT there. And yeah. Okay, so this is wrong. This is totally wrong. Let's put nice sticker. This cannot actually be done because you are just duplicating, creating value. So this is basically will mean that then you have 5 WEF. No, wait, okay, but you have 5 LPT. Wait a second then. Just one moment. And 10 LPT. So 10 LPT here. So 1 LPT. Wait, maybe. So now you have 15 LPTs, 15.5 LPTs here, and these, so total amount, if I do this is the LPT total cross-chain underlying on, okay, total cross-chain LPT. So this is correct. So this guy gets 5, and then once you get 5, you have 5 LPT. So you have basically the same situation, actually. You have same situation here. 5 LPT for this one and 10 for the other one. No, sorry, you have LP1. He redeems. The redeemer function is calculate underlying exchange of LPT. So the one underlying equals total cross-chain LPT, total cross-chain underlying. So underlying amount to redeem equal amount of LPT. So in this case 10 times total cross-chain LPT amount, so is 15 times sorry, divided by total cross-chain underlying amount, so is 5.5. So he gets doesn't look very good. So no, exactly, no, mistake. 15 divided by 5.5 is like 2 times 7 times 10 equal 27. No, it's totally wrong. Doesn't make sense at all. Okay, that makes sense now. That makes sense now. Yeah, but if someone else comes in and put token in base, yeah, he would maybe makes sense. So if another guy comes here, yeah, maybe makes sense. Comes here and deposit other three. Okay, let's do deposit 5, deposit 6, deposit 6 babies. He deposits 6. He gets so he needs to get the other way around, right? He needs to get 15 divided by 5.5. So this is the value of 1. No? So you get 15 divided 5.5 times 6 or not? No. So he deposits 6. How much does he get? Okay. Total cross chain LPT. Total underlying is 5.5 on 15 equals, and this times 6 equals those 2.2. 0.2 here. Just get 2.2. But then make it green. 2.2 LPTs, and then it goes here. And how much he gets? This way is a bit not fair for the liquidity provider. So this way he put 6 WETH. Basically he should get at least the half of not just this. These are corrupted. Doesn't make sense. So this formula is not good. He should get um, 15 on 5.5 times 6, like 16. Yeah, the calculation should be the other way around, should be here EP6, it goes here, and so we do total liquidity pool, so 15, total liquidity pool, but total underlying, so is 5.5, no, not total underlying, but total LPTs, so it's 15. Under total on total underlying times 6, so 15, 5.5 times 6 equals 16, 16.36 LPTs. That would make sense, right? That would definitely make sense. And then it goes here. And then from here, he will get, so he will go here and he says, hey, I have 16.36 LPT on the other chain. How much do I get here? So, wait, because we said that this is wrong or what? No, it's not. So I have here 16 and 36, but I deposited 0, right? So this means this is a bit unfair, because here I will still have the right to withdraw too much, right? So yeah, doesn't make sense. Or not. No. Maybe yes. No. Wait, because these 5, so I deposited 10. So this guy deposited 10 what? Let's make it clear. Okay, so this is, let's, what? On Arbitrum. What on Arbitrum? So here will be 6, not 16. So he deposited 6 wet on base. 6 wet on base. So he now gets, so actually 10, and this is, what count did we do? Is like 10, like this is tot LPT is what? I think 5.5. This is 5.5. Yeah. So he gets in Arbitrum the purple LP. He deposits 6 web on base, so he cross chain goes to Arbitrum. And the LPT dot LPT equals, so pool here we have 15 wet on total LPT, which are 15. Really? Okay. Times 6. So he gets 6 LPTs. Maybe can be okay. Maybe this can be okay. So he gets 6 LPT. So now in Arbitrum we have copy this, and then we have this with 5. So the first one LP has let's do this. Okay. Duplicate LPT and what? Okay, and then so LP has 5 we said, no 10, and we say that he should own 5, but okay. Then this big LPT has 5, and this one the purple has 6. Why? Wet. So you have, so total LPT equal 21. Okay, 21, right? So how much wet? The wet, how much wet? So they have you have to do total liquidity, total underlying, which is how much is the total underlying. So if we say it's 15, right? Still it is 15. So it's 15 time on the total LP, so it's 21 times amount of LP of liquidity provider. So the formula is total this on total this time LP token, right, equals 15 divided by 21.07 times 10 equals 7,142 wet, right, wet. Okay, now this guy is 15 on 21 times 5. 15 divided by 21 times 5, 15 divided by 21 times 5, 3.571 wet. And this guy still has 15 on 21 times 6. 4,28. Total plus 3,571 plus 7,142 equal 14 times 9. Okay, in here, right? Let's do the calculation on the other. Maybe this can work, by the way, maybe. And just making space for the other. Okay, so here in base we have LP1 has 10, and LP2 also have 5, and then this guy has 16.36. Yeah. I don't know. Okay, so the total of LPT here is 10 and 515 is like 31.36, right? Is 15 on the, okay, it's 10. I still have 2 hours though, more or less, and I need to pause the stream. Okay, 31,36 total LPT. In WEF, I need to do total WEF. Total WEF is so I deposited 6 here. How much of total WEF? Then 5.5, right? Yeah, so it's like 11. Should do 11. Should be 11, right? So it's 11 on 31.36 times 10, and this is 11 on 31.36 times 5, and this is 11 on 31.36 times 6, no, times 16.36 equal. Let's move it a bit on this side. Okay, so equal, so 11 on 31.36 equals 0.35 times 10 equals 350. 3,507. 11 on 31.36 times 5, 1,753, and this is 11 on 31.36 times 16.36, 5.7. That doesn't make sense. No, it's still more than I have here. So what the hell? So 11 divided by 31, 36, 0, 35, 0, 350 times 16 and 36, 577, no, oh, 572. 572. Am I missing something? So total wealth is 11, 572, like this is not possible. This is 15, 15, 6, this is 6 and 6.5. actually. 6.5. So 15 on 17 727 11, which is total 11.5. So 11.5 on. So this is the total is 15 plus 17 comma 727 32 comma 727. So this is all wrong. So here is 11 on 31. No, come on. So 11 on 32 comma 727 equals, no, impossible. 11 on 0.3361. 0.3361 times 17 727 595. Oh, sorry. Doesn't make sense. You should get 6, right? You should just get 6. Because no, because he gets further. I'm missing something, I guess. I'm probably missing something. Okay, let's see. 495. 1680. Something is missing. But at this point I got some doubts, like maybe it can be that it's good. So the total of this is not, this is almost 15, and here is almost 15, almost 11.5. This is, we said, 10.99 is actually missing a little bit, but maybe it's just for decimals. So let's do other calculations. So here the total WEF, if you withdraw, if this withdraw, LP1 total is LP1 total equal 7.142 plus 3.361 10.5 I'm doing some mistake, I feel it. I'm definitely doing some mistake. For 28 plus 595 total equals, no, did a mistake. This is okay, so this is clearly wrong, but I'm gonna do that anyway. So LPS 3.571 plus 1.680. Okay, so the problem here is that liquidity provider earns also on the deposit of others, right? So it doesn't, I don't know. Oh, maybe not. So 5.5, how much is 5.5? 5.5 on 5, 1. 1% fee. 1% fee equal 1%. Right, because it's 5.5, so everyone should have totally gained 1%. But this guy deposited at the beginning, he deposited 10 and he just have 0.5. Well, fee 1% for bridge. So, and also the amount, right? So this actually makes sense. It's like one bridge. One bridge, 5 wet, so it's 0.5. So these like this guy, he deposited just 6. Too much. Yep. Because he's also earning on the deposits of others. That's weird. Why though? Because he got 6 LPTs there without any WETH. So this approach is not valid of minting specular LPTs in 2 different pools. Or either it's not valid or I'm doing something wrong. Okay, I'm gonna get some break and then I will come back. I'm back. So, okay, all of this is not good. So I had another idea. So I'm on Arbitrum. And the bridge is toward our base. Okay. What's gonna happen here is that an LP deposit here. Let's do another way this time. Okay, we have these three depositing, and they are depositing, let's say 5 the purple, 7 the pink, and 9 for the orange one. Five wet. And they get back. So they get back. So let's do this. Deposit. Deposit. This guy deposits 5 first, and he gets he gets 5 LPT at the beginning, then he gets deposit function calculation is, we say that deposit calculation is amount of what underlying amount times dot underlying dot LPT. Okay, so this is 5, this is 7 wet times total underlying, which is 5, 7 wet times total underlying, which is 5 until this moment, total LPT, which is 5, right? Total, and then is 7, and then same way he gets 9, right? So because it's 9 times 12 on 12, right? So it's 9. Okay, so they have 9 and 9, right? So then some user bridges from here. No, sorry, the other way around. teleport from here to here. So it got here the user deposit plus, let's do plus okay, plus 6. Plus 6 wet, okay? So the total will be here minus 6 wet, okay? They had, at the beginning, they have total of 16, 21 wet, but then they have a teleport of 6, so they now have 15 wet. Okay, so now after the bridge, they have basically, they have same LPTs, but the total amount is less, is 15 total amount of wet, right? So how much they own here right now? They own LPT, they own deposit calculation, yeah, and so we say that one LPT equals LPT owned times one LPT owned times no, sorry, one LPT equals, not one LPT owned, but equal total wet dot under on, right, dot LPT. Right, so one LPT equals total underline on total liquidity provider tokens. So if we do the math, one LPT equals, in this case, one LPT equals total underline, so 15 divided by 21 equals 0.714. So 2 times 9, 6,42, 0.714, 2 times 7, 4.9 999 0.7142 times 5 3,571 which is equal almost to 15. Okay, but they accrued six point, let's do 1% of a fee, right? So 6 times 0.01 equals 0.6. Let's do 10%, okay, just to be more. So 6 times 0.1 equals 0.6. So this is plus 6. This is not 6, but this is 6 and 6, okay? So here they will have, given that they deposited in Arbitrum, here they have so LPT. So if we are able to see how much LPT one guy start with, okay, we have total of 6.6. Okay, so they have, so one LPT equals total underlying, total LPT. So total underlying is 6.6 on, we say that we have 21, right? 21. Yep, 21. So 6.6 on 21, 0.3, 0.3142 times 9, 0.3142 times 9, 2.8278, 0.3142 times 7, 2.1994, right? And the guy who has 5 is 0.3142 times 5, 1,571 plus 2,1994 plus 2,8278, 6.5, almost. This is almost this. Okay, so if I'm able to map, how much I, yeah, if I, basically what I need to do, given this this thing is that, so wait, so user teleport here. So if I map, what if I map incoming teleports and calc how much of current pool is in the order. Okay, but what if I'm here, I'm another LP here. Yeah, so basically the amount of WEF, what if increase the amount of WEF? So if someone else comes here, in Arbitrum, so you see that you have 6.6 and you have some liquidity provider goes to Arbitrum here. We need a way to, well, we need to separate the WEF accrued as a deposit from LPs and WEF accrued as a fee, as a deposit from the users, right? Can be. So maybe when I do some teleporting, I need to account how much I have for the other fee and take this amount off for the other LPs that are doing this thing. Yeah. Okay, so in cross-chain pool, so what I'm gonna do is this. I'm gonna have my two pools, and then I'm gonna get these, right, two pools. Okay, I just have some message. Let's see who is texting me. No one. Okay, I have two pools. Deposit, all good. I have LPs depositing, and then I have LPs depositing here, and I have users teleporting from here, and then I have other LPs depositing here what I want to do. So when I have a deposit, when I have a deposit, it's okay. Let's start from, let's given for us for granted that we have money there. So let's start from the user. So the user comes here, and here user comes here, does the teleporting. So it's like plus x, come here, minus x plus f, where f stands for fee, f minus x there. And so here in the function, which is CCIP receive, in CCIP receive I need to do like some plus. I need to increment some variable to map the funds that went away, that went off the pool, but that went in the other pool cross chain. So we say that plus x, and we need to add a state variable called s underscore total teleported amount. So we do plus, it's too long, do that, copy, maybe let's call total teleported amount or s TTA. So STTA, to just an abbreviation, okay? STTA plus equal x, right? Plus equal x. So here, when the user teleport at first, we need to, in CCIP send, we need to have a variable also in this pool, the convert amount out TTA in plus equal x plus f. Yeah, s plus f. Then when the liquidity provider comes, we basically so when the liquidity provider comes and deposit, and then deposit, it's all good, but when the liquidity provider want to withdraw, the total amount that he can withdraw, total redeem. This is not withdraw, but is redeem. Redeem. So the total redeem equals equals basically equals so 1 LPT, so total LPT amount, LPT amount, need to move it, times total LPT under total underlying minus this minus yeah, okay, maybe I found a cool way to do that. Total redeem on current network and total redeem and redeem on, well, cross chain is chain equals LPT amount times dot under dot LPT total under, no, is not total 9, but is like, is actually not this LPT amount times total LPT, right? Total LPT of this network out, yeah, is the out s underscore total teleported amount out. That makes sense. Makes sense, guys. It makes sense. Okay, nice. Maybe let's try to do that. Maybe let's do the last simulation here. No, but I did it. So because I deposit here. Yeah, because I did. Yeah. This is not this, but this is one LPT. Okay. Current chain. Yeah, but that makes sense. Okay, let's try doing that. Let's try doing that. I don't have a lot of time though, but let's try. Okay, let's try doing that. So first, when I deposit, so when I deposit, so okay, I need to create two new variables, right? Or not? Yeah. No, just what I need to see what goes out for sure and what goes in, right? Minus what goes in, which is from the other for the other chain, and cross chain is what goes out. Yeah, so I need in and out. Okay, I need in this cross chain pool. I need to have another variable, uint 256 private total underlying out, yeah, uint, and the other one is total underlying in. So I want, let's write it to just to make it clear. So I want to take this in account when doing the cross-chain redeemable. And this I want to, okay, and for this, why am I taking this? Okay, I want to subtract that from total supply when doing current chain. This amount is for the cross chain LPs. Okay, that makes sense. That makes sense. Actually, guys, I'm so excited. Okay, so when I send the message, constructor, deposit, redeem, add cross-chain sender, start teleport. Maybe I can just call it start teleport. I will call it start teleport. Teleport replace with teleport. And just call it teleport. So in teleport, okay. Okay, so I need to map the in token, right? So I need to go, I just made a mistake here. S underscore, and also here S underscore. No. No. What am I doing? Total underline in. Total underline in. Total underline in plus equals value. Okay, and when I receive, no, I didn't solve this problem then. Come on. Total underline in, it's what I need when going here. This is, we can delete that. Teleport function ID. So CC receive, save transfer. What am I doing here? Transfer to value. Okay, and so I need to do, so total underline out plus equal value, right? I thought I was done with this error. Come on. Just not possible. Come on. Okay, CCP receive. Is it correct? Out, in. Yep. Then crazy. Then when I do redeem, I do redeem. Yeah. LPT amount, to bar. Also, it should send a message across. Well, it redeem. Maybe I can do two functions. Maybe not. I don't know. Maybe I want just one function to redeem on this current network, and another one to redeem on the other network. I'm also thinking of another problem, so no, maybe. So I'm thinking about what happens if someone comes to the other network and he use what the liquidity I got here. It's very tricky. Okay, maybe let's do this for now, and then I don't know, because I need to also take in account that the liquidity I got on the other chain can be used again. So basically, if I'm a liquidity provider in this network, and then someone teleport from the other network, gives me money there, deposit money in that pool, and then next time it will come back from this to the previous one, so he gets the money there. So this is not correct. This is actually not very good. How can I resolve that? Maybe it's not a problem, I don't know. It is a problem. Okay, well maybe I can count how much total there is in the other. How much in total is this in this? I don't know. Maybe this thing is not ideal. Maybe this is not ideal. Because what happens if this it looked good but it's not good, because what happens if this this thing gets bigger and bigger. And then I cannot really do that. Maybe I can keep track of how much there is in the other chain, how much I have here. Maybe I can map how much a user deposited. So I can say I deposit 10. Then I can see, okay, how much do I have now? I have less. Okay, that means that the percentage that I'm missing in this chain I should get from the other chain. If the total amount is more, I need to basically what I need to do if the total amount is more. I don't get fee. Maybe I just count the fee. What if I just count the fee? What if I just count the fee? Yeah, I need to really think about that. I'm gonna take a break. Okay, I'm back. So yeah, maybe I got it. So basically, I need to think about the two networks as a single entity, right? So I need to know in every time how much WEF I have in the two pools and how much LPTs I have in in each pools, and I need to I need to always get these two informations. So if I always get these two information, then I can easily, if I have total cross-chain pool WEF and total cross-chain LPTs, I can always be sure how much I can redeem in the yeah in the current network, and how much I can redeem in the cross-chain network, right? So in order to do so, I need to I don't so I need to do that. So in the cross-chain, in I'm just gonna delete that. So uint 256 total no cross private cross chain underline balance storage, and this will be storage cross chain LPTs liquidity pool tokens. Okay, so when I do deposit, this is false. Well, this is true, but notice this function should send a message updating updating this these two updating and this. Yep. And then deposit and redeem. Same. When I redeem will do the same basically, and also so will do the same, and also what? Yeah. Should update it in this what does, so this basically, yeah. Okay, so I should update here. I can update for the other blockchain, and there I will update on this, right? Yeah. Redeem and add cross-chain sender and teleport. Notice this function should send a message creating cross-chain should also send a message updating the balances, right? So cross-chain balance and cross-chain pool tokens, and actually and also update here, right? So let's start with teleport. So send CCP a message teleport the client. So when I'm sending this, I know that on the other chain the total, wait, I should have back underlying balance, underlying balance. Okay, so this in here, when I'm sending message teleport, I want to cross-chain underlying balance. Nice. I also, no, this is also nice. Minus equal value, right? Because I'm depositing here and I'm getting there, and I'm depositing, the user is depositing here, user is the depositing on this network and with withdraw in the other minus equal value. Okay. Yep. And also if cross-chain, well, like what we do, minus maybe reading it would be like no, that makes sense. If cross-chain underlying balance, so if the balance on other chain, if the resulting, if the balance on other chain is less than 0, stop, revert. No, this is nice. This is also very nice. If, well, minus equal 0, and I need to do this unchecked. That this is, yeah, maybe I need to do that. Do this. Oh, it's like unchecked. This. If cross-chain balance minus equal value check for gas. Why? If cross chain minus value mean less than or equal less than 0, less than or equal 0, cross chain pool, we call it not enough balance on destination pool. Cool. Okay, time is running out, but I think I got it. So if this minus this is less than or equal to 0, revert. Otherwise, just subtract it. And then send CCP message. Yeah, that's all, right? Send CCP message teleport. Then internal CCP internal. Let me move this up. Here, if it's a teleport function, I'm receiver, so I'm in the destination contract. I will do exactly this. So I want to map this cross-chain balance plus equal value, right? Yeah. So I know that now the other chain has this value, and actually, yeah, it should be the value plus fee. This should be the value, should be plus fees. Value, message value. Yeah, but this is for the sending the CIP. Exchange letter, message. Message. Okay, the value build teleport message. Value. Yep. The value. Simulate teleport. Yeah, okay, I'm gonna do it later maybe. Okay. percentage etrom. Yeah. So now this is okay. No, let's do the fee calculation now. So calculate underline blah blah blah. Okay, I need to review this and this to do review. Teleport, get router, total underline plus value. Yeah, the fee are paid in notice fee are paid in underlying token. Okay, in underlying token fees value, get value total underlying plus equal value plus fee, right? Let's do some calculate fee. Build teleport. Okay, this is calculate fees. Value. Notice and calculate fixed fee of, I don't know, 5%. Let's do 5%. No, what did I do? Something wrong. Okay, calculate fee value. Let's do this, and then param value the amount to calc the fees for, and then returns. Maybe this can be public, I don't know. Return value plus fees. Return value plus fees, uint 256. So value plus fees equals, we need to do 5% of the value, right? So value, I say it is like value times no, how do I calculate percentages? How do I calculate percentages in Solidity? This is interesting. Interaction, blah blah blah. Before we jump straight into Solidity bits, we should look up blah 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 blah. Calculate percentage of x. You use the following formula: epsilon y equal x time p. This one to do. What p? 25% of 100. Doing the math in your hand. We know that. Let's plug the numbers and see what happens. Times 100. So this is the formula. So x times percentage on 100. Yeah. Yeah. Basis points. Yeah. Yeah. So amount value plus value times BPS so 1 BPS is equal to 250 BPS 2 so 5 will be 748, yeah, 500 BPS. Yeah, 500. Yeah, maybe we'll do 10,000 in that. Yeah, 500 BPS. Okay. Let's do another constant private 500 fees 500 fees BPS. Okay. Like this. If yeah, but actually amount times fees BPS is less than 10k. Right. I should test this ideally. Let's see, helpers, cross-chain pool, factory test, pool test, yeah. Function. this function is better if we create a public version of it. Just make it public. Yep, we just make it public. Then I will do X, and then I will do internal public here. Calculate fees, cross-chain pool test calculating fees, and let's see, so calculate fees of one E18 cross-chain pool dot calculate fees 118 fees, calculate this value, calculate amount plus fees, calculate amount plus fees, uint 256 plus fees equals this. So should be 5% of 1E E18 1E18 plus 5% of 1E18. So plus fees. Now assert EQ plus fees equals so this will be 5% of 118 is how much? I don't know. Is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. This is 118, and 5% of that is let's try. So it's 1, 2, 3, 1, 2, 3, 1, 2, 3, plus 5 0 0 0 0 0 0 0 0 0 0 0. So is 1E 3 6 9 12 13 1E 13 1E 18 plus 1 3 13. Let's see if that works. Forge test is calculating fees. What? Oh, empty test calculating fees. Okay. Amount, of course, is wrong. This is value. This is amount. Is not amount. This is value. Value. This value. Teleport was it different? Cross-chain teleport, cross-chain. Wait, I'm not doing that. I'm doing. Sorry, maybe I should just delete that because I just did it here, right? Yeah. Okay. Fee does calculating fees, fee cross-chain pool, right? Cross-chain pool, just teleport. Assertion. And it's a mistake. This is 5%. How much is calculator online? 1E18 if is plus 5% of 1E18. Does it make sense? I don't know. Yeah. So find it 5E13. Sorry. 5E. No. Do we? Okay, 5E18. Okay, times 0.05. 2.517. Okay, 5E18. Well, 5E18. No, 5. Sorry. 1E18 plus 1E18 times 0.05. 1E05 and E18. Yeah, I think it's nice. So this is correct. 1, 2, 3, 1, 2, 3, and 6. No, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 12. 1, 2, 3, and this is 12, 15, 18. So okay. How do you write it? It's like 105. Okay, let's say that looks good. Yeah, so yeah, so this sends CCIP message. I'm subtracting the value. Cross-chain volatile balance association chain, cross-chain underlying balance minus equal value. Okay, reply CCIP receive. I update here cross-chain underlying balance. Okay, it's value actually. Oh, let me check also this. Let's just calculate fees. Calculate fees. And the test will be 1E15 makes sense. Okay, 5E15. Yeah, that makes sense. That actually makes sense. Okay, let's calculating fees. So here, calculate fees. Just go here. What I do is calculate teleport router. Save transfer for message sender. Calculate fees of value. Int 256 fees equals calculate fees value plus fees value plus fees and here minus value int 256 fees value fees message value build teleport message. The teleport message is cap. So value fees cross chain underlying balance is value. And here the message interverse message value. Yeah, I think I need to send build teleport message encode value fees to value uint 256 fees. Yep, definitely fees. Need to pass also fees because you want to build teleport message by fees equals uint 256 fees equals what is it? I think I lost one. It's a mistake. What? Yep. Okay. Cool. I need to switch off a little bit the simulator. So teleport fees, well, calculate fees value, and then we pass fees here. Value fees, send CCP message teleport value fees and 2. Teleport message value fees 2. Okay, and then message. Okay, cross chain underlying balance would be minus value. Okay, the message. Then when I receive, transfer to cross chain underline balance value plus fees value uint 256 fees, and then I need to add we got uint 256 address. Cool. Now makes sense, makes more sense. Perfect. Okay, I built, so recap. What I did is I just so I did these things on each pool. I now have a cross chain balance, right? And then what do I have is cross chain balance, and I have cross chain underlying balance. Yeah, let's say I have this. Let's, for commodity, X chain underlying balance and X chain LPT balance, and in teleport I will basically, when it called teleport, I will do minus equal amount teleported here x, and this is y, x minus equal amount teleported. So this cross-chain balance, so in the other pool I will subtract that the amount that I'm teleporting, because I'm depositing in the current and withdrawing in the other one. And in receive, I'm doing x plus equal amount plus fees. Okay. Oh, I didn't share it. Okay, this is what I did. So in the pool, I added these two variables: cross-chain underlying balance and cross-chain LPT balance, right? I'm taking care of cross-chain underlying balance. So in teleport, I'm subtracting the amount teleported from the cross-chain underlying balance when users do teleporting. So from chain A to chain B, they deposit on chain A and they get out from chain B, right? So they increase the amount on chain A and they decrease the amount cross-chain, right? The amount of the underlying cross-chain. On the receive function, I do the opposite. So I increase the amount cross-chain and I add fees as well. So I take in account also the fees. Okay, I need to stop for at least, I would say at least 2 hours, no, 3 hours. Okay, I will stop the streaming and then we'll keep it up this afternoon. Nice, thank you guys.